So last I given you the question. These are the 3 questions as a homework. I guess all of you did. Remember, take up as a proper class as you attend in the classroom and do the things. You will see the results slowly. Okay. So every class, if there is the homework, you must do it and verify you got the correctly or not. Or any other method, means what method you got it, what is the my method is the same, because Olympiad question is something like every question will have more than 2-3 methods. In fact, as a teacher, I also don't have that many methods as many students we have. So here student is always superior, who's having the good brain and they do practice. So they will have more logical answers and all. Okay. So anyway, let's continue because we should not waste time. It's a first question is saying n belongs to integer. N belongs to integer, right? Prove that 3n square minus 1 cannot be perfect square. I will try to solve by the different methods. Okay. Let's see one by one. Each method will try to explore. Very simple question. I hope all of you got it also. It's not because, as I told you, this is the first round of problem solving. First round is very basic. In fact, less than PRMO level also. Understand? That second round only it will start. Why second round? I'm talking that key. Why not directly? You'll see that key. Maximum times Olympiad class taking place directly start with the question. Why I don't start with the directly question? Because real question when you solve, you should have all the idea in your mind, then only you can attempt on the question. Otherwise, you have to go through solution every time. Okay. So we have to prove that 3n square minus 1 is a perfect, cannot be perfect square, perfect square, cannot be perfect square. Whenever they are saying that this cannot be happen, or prime number cannot be happen, or composite number cannot be happen, something cannot be happen, assume it can happen. Go by contradiction method. That's more perfect way of solving the question. So first, I will not go by the correct. Let's go by the method 1. Method 1 I will take up by simple logic. And listen me carefully. Method 1. What is that? I have to check this one. What I will do? I'm going to talk about that. Let by n is any integer. So I am taking n as, let n equal to 3m. What are the possible? 3m or 3m plus 1 or 3m plus 2. Correct? Yeah, I hope all of you remember yesterday's class, last class, ki perfect square of any integer will be either in the form of 3m or 3m plus 1. Remember all of you. Okay? Either this form or this form. No other form is possible. If any time you get 3m plus 2 form, because any integer will be either 3 form, but perfect square will be in this 2 form only. I hope all of you, we proved also. Some people are looking at me. Yeah, see, prove that the square of any integer will be either in the form of 3n or 3n plus 1. Okay, so either it will be in the form of 3n or 3n plus 1 only, it will be there, right? So I'm not saying if any integer in this form, so it will be always perfect square. No, I'm not saying at all like that. Like 12. 12 is also 3m form, but this is not a perfect square. But if it is a perfect square, 100% sure it will be either in the 3m form or 3m plus 1 form. Every time I'm writing m, are you able to understand? M means any integer. Means 3 times of some integer or 3 times of some integer plus 1 format. Take any integer 16. That is the 3 into 5 plus 1. Any integer 25, 3 into 8 plus 1. Are you getting? 49, 3 into 16 plus 1. 9, 3 into 3 plus 1. 3 into 3 means this form. So every integer square will be in this format. So from here I got the idea. Let's check one by one. First I'm taking n equal to 3m. Okay, 3k let's take it. M or k doesn't matter. 3 into some integer. Okay. So n equal to 3m, if you will put it, what you will get? You will get what? 9k square. So that will become what? 9 and 27k square plus minus 1. 27k square minus 1. All of you know that I can change this because I want to see either this form or this form or this form. So I can write 27k square minus 3 plus 3 minus 1. Correct? So this will become what? 27, 3 I can take common and get 9k square minus 1 and plus 2. So this is the form of what? 3m plus 2. Means if n is 3k, this will be coming in the form of 3m plus 2, and 3m plus 2 if form is coming, that 100% sure it cannot be a perfect square number. That cannot be perfect square number. Again and again I am telling, if you are knowing it, please excuse me for that, because sir, why you are taking that much slow? I wanted to make the person who is learning first time very concept clear. If form of any number is coming 3m or 3m plus 1, I don't know, it may be perfect square, it may not be perfect square. But if the form is coming 3m plus 2, any integer, so 100% sure it will not be a perfect square number. So don't misunderstand that. Second possibility, what can be happen? Why n can be, second possibility, n can be 3k plus 1. That also can happen. Yes or no? Put 3k plus 1. You will get 3 into 3k plus 1 whole square minus 1. I'm not going to do much drama. If you square it, what you will get? 9k square plus 6k. So 9k square plus 6k into 3. So that I can simply write 3m. And plus 3 minus 1. So plus 2. So this is also the form of what? 3m plus 2. Have you understand this step? How I wrote it? 3 into 9k square plus 6k plus 1 minus 1. So this I can write it as 3 into 9k square plus 6k plus 3 minus 1 means plus 2. This is some integer which call it m. So I wrote 3m plus 2. That means if n equal to 3k plus 1, then also the form is coming 3m plus 2. So if n is 3k or 3k plus 1, that is the 100% sure this quantity cannot be perfect square. Now last possibility. Last possibility. What is the last possibility? Let's think. N equal to maybe 3k plus 2. If you put it here, you will get 3 into 3k plus 2 whole square minus 1. If you square it, first two term will be surely perfect 3 into something. So that will be 3m plus 4 into 3, 12. 12 minus 1, 11. And 11 I can write what? 9 plus 2. And this is again 3m form. Again 3m form. So this again is coming 3 into some integer plus 2 form. So this is also 3m plus 2 form. Means this is always in the form of 3m plus 2. This is always in the form of 3m plus 2. 3n square minus 1. For any integer n, it will always in the form of 3m plus 2. So 100% sure. One thing is very sure. If any integer in the form of 3m plus 2, that cannot be a perfect square. This is the one way of proving. I'm sure you are able to understand all of you. Is it clear? Last lecture, if you miss it, please, it will be a problem for you. So you should simply click on that one and try to go on the first lecture. If you miss that, number theory should be starting from starting. Right? Okay. But don't you think that it's become so lengthy? Of course, I'm not interested to teach you how quickly can solve the question. If you are very much perfect in number theory and all, so this lecture is not for you. This lecture who is going to learn number theory. So I'm not interested in much how can we solve quickly. But just for curiosity, I'm giving you method 2. There's a more perfect method, which you will do by this method only. Once you will understand number theory, you will never do by this. Nobody will do. But this method teaching you something. It's telling you that whenever in future any number you want to take as a 3m and 3n plus 1, 3n plus 2, put it and verify the things. So every number in whole mathematics, either it will be in the form of 3n, or 3n plus 1, or 3n plus 2. This is the what I am trying to stress on it, right? But actually what should we do? I have to prove 3n square minus 1 cannot be a perfect square. I am going by contradiction method, and I am assuming, let's assume 3n minus 1 equal to k square, and this is my assumption 1. Correct? I assume this is the square of some integer where k belongs to integer. This is my assumption. What I am trying to do, I will try to prove it wrong. Okay. Shift here. What will get? 3n square is equal to k square plus 1. Did you understand? Hello? Okay. Now, think carefully. If we divide by 3 both side, then remainder must be same both side. Yes or no? Why both are same number? Means whatever remainder will come here by dividing 3, same remainder has to come here. That is very sure. Did you understand? Okay. Let's divide by 3. If we divide by 3, the right side remainder will be equal to 0. Why? Because this is the multiple of 3. Not right side, left side. I'm sorry. Sometimes in the night viewing is difficult. Okay, left side. Right side. If you divide by 3, think k square. You already assume it's a perfect square of an integer. So, if you divide by 3, remainder will be either 0 or 1. Why? Hello? Excuse me. Prove that when a square of any integer divided by 3, the remainder will be either 0 or 1. In the second lecture, we discuss about that. Am I right? So, those things, you have to use it. So, what is the possibility? Either remainder will be 0 this. If this remainder 0, so here remainder will be 1. Because if you divide by 3, you have to divide here and here. So, here remainder suppose 0. So, here remainder will be 100% 1. So, 0 plus 1, right side remainder will be 0 plus 1, or maybe this remainder can give you 1. So, 1 plus 1. Means right side remainder will be either 1 or 2. Right side remainder will be either 1 or 2. And left side remainder is 0. How is it possible that left side remainder will be equal to right side remainder? And if the remainder is not same, so 100% those two numbers will not be same. But if two numbers are equal, and if you divide by the same 3 or 4 or 5, so their remainder both sides should be same. Otherwise, how the number will be same? It means that indicate that 3n square plus 3n square cannot be, this implies 3n square cannot be equal to k square plus 1. This implies 3n square minus 1 cannot be equal to k square, means our assumption 1 is wrong. Our assumption 1 is wrong. Be clear? When you go beyond the PRMO, you have to write subjective answers, so you have to write the steps properly. On the steps only, you get the marks. All of you know, for the INMO, there is the only 6 question used to come 3 hour, 4 hour. 4 hour used to be there. So there, your steps matter a lot. Understood? Did you understand the question? Is it clear? So, what way we did? First, we did by very basic method. We assume n equal to 3k, 3k plus 1, 3k plus 2, and we put 1 by 1, and we proved in every form, either n equal to 3k form or 3k plus 1 or 3k plus 2, it will n3n square minus 1 is always 3m plus 2 format. So, that cannot be a perfect square. And next one is the oral question. Means orally you can do it. Basically, I am writing, that's why I spent this much time. Right. Next. What is the next doubt? Not doubt, homework. Prove that n into n square plus 2 by 3 is always a perfect square. N belongs to natural number. I hope now very easily you can do it. Same logic you apply. What same logic? What same logic? Ki n equal to 3k, n equal to 3k plus 1, n equal to 3k plus 2. And always try to see that ki this is the this is going to satisfy that condition. Always perfect square. So this is the perfect square you have to do. Right? You want to try once more? After giving this hint, please try once more. No, I'm not going to give you time. Pause the lecture and try it once more. Those who did not get. Got it? Okay, let me solve it. Prove that n into n square by n square plus 2 by 3 is always a perfect I think I given the wrong question. In hurry, I'm sorry for that. Is always an integer. Perfect square, it cannot be happen. Always an integer. Because n equal to 1 if you put it, n equal to 1, so it's a perfect square. N equal to 2 if you put it, see, 4 plus 2, 6 and 4 it will become. N equal to 3 if you are going to put, so 3 into 9 plus 2, 11. 9 plus 2, 11 divided by 3. 3 will get cancelled and it will 11. 11 is not a perfect square. So actually I given the wrong question, I'm sorry. Not actually, this was going in the mind and I mentioned that one. So n into n square plus 2 by 3 is always an integer. Now I hope nothing is great about this question. It's a very simple. Easily you can tell how it will be solved. How it will be solved? N equal to, there is a maybe possibility n will be equal to 3m. If it's a 3m, so put it 3m here. So 3m into 9m square plus 2 by 3. 3 will get cancelled and m into 9m square plus 2 will be surely always integer. And n equal to, another possibility, n equal to 3m plus 2, 3m plus 1. So this value will become what? Hello. This value will become what? 9, look carefully, 3m plus 1 into 9n square plus 3m, sorry. 3m is 9, 3m. Just I'm putting 3m plus 1 whole square, I'm expanding. So 3m plus 1, so that will become 6m and plus 1 plus 2. So you can see from here 3 will be common. 3 will be common and cancel. And n square, if you are going to put n equal to 3m plus 2. 3m plus 2. Then it will become what? 9n square. 3m plus 2 into 9m square plus 3 2 6 12 12m plus 4 plus 2. Now see, 4 plus 2 6 and here also 3 will common and cancel by this 3. So this will be always integer. It's a very simple question. Actually I was thinking something else and I given something else. Right, this kind of the calculation mistakes and all can take place, so please excuse for that one. Next question, find the number of integral solution of this question. It's very simple. If you remember the first lecture of the number theory, from there easily you can do. We have to find out the number of integral solution of this equation. Means a and b are integer. Of course a and b cannot be equal to 0. I hope you can understand. In mathematics, denominator 0 is not allowed. 1 by a plus 1 by b equal to 1 by 3. Correct? Let's modify it. So what you'll get? A plus b by ab equal to 3. 1 by 3. Or you can say 3a plus 3b will be equal to ab. Shift one side, 3a, shifting this side, to 3b is equal to a common b minus 3. I hope you are able to understand. So a equal to 3b by b minus 3. Since a and b both are integer, so what you are going to say? A equal to, we'll say 3b minus 9 plus 9. Have you understand what I did? I just added minus 9 and subtracted b minus 3. So a equal to, take this pair. So we'll get 3 plus 9 by b minus 3. Try to recall such kind of question we did. A is integer and this is a 3. So this should be integer. Means 9 by b minus 3 must be integer. 9 by b minus 3 must be integer only, means b minus 3 will divide 9. Yes or no? B minus 3 must divide 9. B minus 3 must divide 9 means B minus 3 must be equal to factor of 9. So that is what? Plus minus 1, plus minus 3, plus minus 9. Yes or no? I ask you natural number or integer? Integer solution. Okay. So B minus 3 equal to this. So B will be equal to what? If you add here, so 3 plus 1, 4, 2, R, 6, 0, R, 12, minus 6. Yes. But 0 I will reject because B cannot be equal to 0. B equal to 0 I will reject. Did you understand? Okay. So what is the value of B? We got it. Minus 6, 0, 2, 4, 6, 12. So how many solution? 1, 2, 3, 4, 5, 6. 6 solution for B. So 6 solution for A also will come. Understood my point? This value you can substitute here. So you'll get the value of the A. Anyhow, they didn't ask you that what is the value of the A and B. They ask you find out number of integral solution. So we'll say 6 integral solution. 0 I included. I'm sorry. 0 will not be included. Sorry. Minus 6, 2, 4, 1, 2, 3, 4, 5. 5 solution will be there. I'm sure it's clear to everybody. Is it right? Understood all of you? Now, chaliye, let's do some more question on this and then we'll wind up this topic. This particular Euclid Division Lemma will get over. So write another question. Prove that square of any odd integers will be, I think I didn't do this question. Sometimes I used to forget what kind of question I did and what is not did. No, I didn't do. Okay. See, these are the simple theory actually. I'm creating in form of question and I'm trying to explain you. Prove that square of any odd integer will be in the form of 8m plus 1, where m belongs to integer. Right? Very simple, easily you can do it. I don't have to explain also. Any odd integer square, how will you write it? 2n plus 1 whole square. 2n plus 1 whole square will be equal to what? 4n square plus 4n plus 1. So it will be 4n will be common into n plus 1 here from here plus 1. Now listen me. N I don't know what. N may be even integer, may be odd integer. I don't know. So suppose n is even. If n is even, to n plus 1 will be odd. If n is odd, to n plus 1 will be even. Because on the real number line, structure is like this. Even, odd, even, odd, even, odd, even, odd, like this. Like this. Yes or no? Every even number bounded by 2 odd and every odd integer is always bounded by 2 even. So, 2 consecutive integer, if it's multiply n into n plus 1, I will say 100% always even. Other logic also you can apply. What logic, sir? N consecutive integer, if you multiply, it will be divisible by n factorial. So n into n plus 1 will be always divided by 2 factorial. 2 factorial means what? 2 into 1. Yes or no? Means 2. So means this is always divisible by 2. It's always divisible by 2. Means always even number. So this is, I can say, it's always even number. This is always even number. Yes or no? So I will say this I can write 2m. So it will become 8m plus 1. It will become 8m plus 1. Means square of any odd integer will be always in the form of 8 into some integer plus 1. How will you read? How will you read this question in different language? Whenever we divide any odd integer square by 8, then remainder will be always 1. When we'll divide by 8, remainder will be always 1. Both are same meaning. Both are same meaning. This is the way you have to visualize. You have to think what are the different possibility can be happen. Did you understand? Any odd integer is square always will be in the form of 8 into some integer plus 1. You can verify also. Take some odd integer. Hello. 3 square. 9. 9 is the 8 plus 1. 5 square. 25. 25 is the 8 into 3 plus 1. Correct? 7 square. Odd integer square we have to do. That will be what? 49. 49 is the 8 into 6 plus 1. Are you able to understand? Hello? 9 square, 81, 8 into 10 plus 1. So, odd integer square will be always 8 into some integer plus 1. I hope able to understand everybody. Is this clear? All of you able to understand? Good. On this basis, now oral type of question. This you remember, please. This as a note somewhere mention. I will mark it as a note. Odd integer square. Every time I will use will be always in the form of 8m plus 1, where m is some integer. Where m is any integer, maybe positive, maybe negative. Did you understand? Of course, it will not be negative. You know it. This is a square quantity. Square quantity cannot be negative. So, no chance of negative. Okay. It's just for saying, I'm saying integer. 8m plus 1 format. So, simple question. And I'm expecting everybody quick answer. If n is odd integer, then prove that 8 divides n square minus 1. Hello? Yes, I don't have to solve. By n is odd integer, so n square will be 8m plus 1. So 8m plus 1 minus 1, 8m. So this is the form of 8m. It will be always divided by 8. Yes or no? Next. If a and b are odd integer, then prove that a square plus b square is even but not divisible by 4. Very simple question. A is odd integer. So A I can write 8 into some integer plus 1. I am writing m1 plus 1. You know why I didn't write m? Because B also we have to assume. Na? So one I will take m1 and another I will take m2. And B I will take, A square. B square I will take as a 8m2 plus 1. So A square plus B square is nothing but 8 into m1 plus m2 plus 2. You can see very clearly 2 also you can take common from throughout. So this is the even integer, but if you divide by the 4, this is divisible by 4, but this is not divisible by 4. Remainder will come 2. Remainder will come 2. They may ask you this question in the other way. If a and b are odd integer, find the remainder when a square plus b square divided by 4. Remainder will be 2. See, one small point can make things so simple if you think carefully. Are you able to understand? Yes or no? I am not saying that this is the only. Like this, so many cases will come. I am just trying to tell you how to convert case as a solution for you. Right? Next question. If sometimes in hurry I give the wrong questions also, so please excuse for that, because this is not questions, this is just basic foundation of the number theory. If a and b are odd integers, integers. Then prove that 16 will divide a power 4 plus b power 4 minus 2. Would you like to try? If yes, please pause the lecture and try to solve this question. If yes, don't do dishonesty. Pause the lecture. Try. You can solve it. I'm 100% sure. You are not sure about yourself, but I am sure. If you are listening lecture properly from starting without jumping here and there, not like watching on YouTube. Some game is going on, something, and wasting time. Read as a classroom. I can assure you that there is no problem in the PR. At least PRMO will not be a problem. Remember, RMO, INMO, 50% rule is more than 50% rule is the student rule. But PRMO, if properly any teacher teach you, easily can be, any average student also can clear PRMO. PRMO is not very much difficult things. And one level if it is cleared, PRMO also if you can clear it off, then we get a confidence. And what we learn, it never go in waste. Either in future you prepare for JEE or other examination, all these things, logical thinking will always help you. Always will help you. Chalo bhai. Let's do 16. We have to prove 16 divided by a and b are odd integer. A and b are odd integer. A and b are odd integer. Oh, if I can bring a square and b square, I will be very happy. Why? Because I know if a odd integer, a square can be written as a 8 into m1 plus 1. Yes or no? How will I? Yes. We can write this way plus this way. This minus 2i spread. This what you can write? A square minus 1 into a square plus 1. And this you can write what? B square minus 1 into b square plus 1. Oh. A square. I can write what? 8m1 plus 1. 8m1 plus 1. So this will become 8m1 simply. And this will become what? 8m1 plus 1 plus 1. Means 8m1 plus 1 means 2. Plus this will become 8m2. And this will become 8m2 plus 1 means plus 2. I don't think further I should solve. From here 2 I can take common. So this will become 16. So 16 here also 2 are common. So 16. 16 I can take common. So I'll get m1 into 4m1 plus 1 plus m2 into 4m2 plus 1. All of you agree with me? m1, m2 are integer. So these are some integer. So I will say this will be 16 into some integer. Some integer. That means a 16 will divide a power 4 plus b power 4 minus 2. How simple is it? With one small logic कि भाई odd integer square value will come in the form of 8m plus 1. Did you understand? Yes or no? Just one question going beyond your PRMO style. Just to show you कि what we learn, it always helpful. If A, B, C are odd integers, then prove that ax square plus bx plus c equal to 0 cannot have real roots. Those students who listening these lectures and don't know quadratic, so don't worry. I will teach you polynomial, their quadratic in details will be done. Not to be worried. This is just for to change the test. Same thing seating every time. So we get the fed up. Look at here. How beautifully it can be done. You know, cannot have rational roots. I'm sorry. Change the question. Cannot have rational roots. Rational RF, you know. any number which can be in the form of, expressed in the form of P by Q. Okay. Rational root. Those students who don't know quadratic, they may face problem of this solution. But otherwise, you know, any quadratic equation, ax square plus bx plus c equal to 0, will have rational roots. Rational roots only if a, b, c are rational. Q is the symbol of rational. Understand? And d is a perfect square. Is a perfect square. A, B, C must be rational and D must be perfect square. This is the condition for the any quadratic to have the rational roots. What is the condition? A, B, C must be rational. A, B, C must be rational. And D must be a perfect square number. So 100% of the roots will be always rational. Any rational roots, if you find, D will be a perfect square. D will be a perfect square. Chalo bhai. If by here, first condition already satisfied, because they are saying ABC odd integer. Every integer is the rational number only. So first condition already satisfying here. Only one more condition we have to prove. If I can prove D is a perfect square, then roots will be rational. If D is not a perfect square, then roots cannot have the rational. Cannot be rational. Let's calculate D. D will be what? B square minus 4AC. Hello. B square minus 4AC. But all of you know, B is, I'm assuming, it's having rational roots. If it's having rational roots, so B square minus 4AC must be equal to K square. B square minus 4AC must be equal to K square. I'm assuming, let this. And I will prove this assumption wrong. Then only we can say it cannot have rational roots, because first condition already satisfying. Second condition only hope is there. I have to prove that this is wrong. If this become correct, ABC already rational, this is also correct, so totally roots will be rational. And we have to prove we cannot have rational roots. Am I right or not? Yes. Okay. I know about B. B is odd integer. I know about A and C. They are odd integer. Do you know about A? K? K is odd. How? B is odd, so B square will be odd. Odd square will be always odd. And this is the even. Why even, sir? 4 multiplication is there, right? So even, odd minus even will be always odd. So K square will be odd. K square odd, so K will be also odd. Did you understand? K square odd, so K is odd, so K square will be also odd. So K is odd. Okay. I can change this one to B square minus K square equal to 4AC. B square I can write what? 8M1 plus 1 minus K square what I can write? 8M2 plus 1 is equal to 4AC. Now if you expand it, 1 will be bye-bye. 8M1 minus M2 equal to 4AC. 4 bye-bye, and you will get what? 2 into M1 minus M2 is equal to AC. Already they mentioned A and C are odd, and this is the 2 into some integer, this is the even, equal to odd. Odd into odd is already odd, which is impossible. Which is impossible. That means our assumption is wrong. Means B square minus 4AC cannot be K square. B square minus 4AC cannot be K square. Means B square minus 4AC cannot be perfect square. And B square minus 4AC cannot be perfect square. Means roots of this cannot be rational. Just I'm trying to tell you. See, this question is the for the JEE, for IIT students who do the quadratic for the JEE exam and all. It was asked in some JEE very old time also, this question. What I'm trying to tell you, number theory, if you are learning, it's going to help you. I'm not saying that everybody is going to get top 5 in the Olympiad, they will reach it. If that is, only 5-6 students will be selected for the final goal. So, sir, I also don't know, means I'm an average child or the above average little bit. Can I dream for that? Yes, you should dream for this. But by chance, if you are not reaching, it doesn't mean you wasted. You will see any student who prepare for PRMO and RMO properly, their mathematics for the JEE is the perfect. I've seen so many students. You can see very clear difference between the student who never thought about the PRMO and RMO and one student who thought about the PRMO RMO. There is a clear difference, and this is the clear difference. The student who's never heard about number theory, when he will do this question, he will face lot of problem. But the student who did, for them, this is the chinnu munnu question. Understood? Chali. Lot of talk over. Let's go ahead and do some more questions so that we can wind up this chapter. Not this chapter, this particular segment. Write a question. Find number of solution. Find number of solution of the equation a square plus 16b is equal to 5, where a and b element of integers. Remember, such kind of question can be done by the congruency very easily. Congruency method very easily. We didn't learn those things, so we will be depending only on our Euclid Division Lemma. And on that logic, that is a very powerful actually. It's not a simple thing. Try to understand. Look, concentrate on this equation. A square plus 16b equal to 5. First thing, tell me, if any square, any integer I'm talking, any integer is square divided by 4, what the remainder will come? Last class we discussed. By chance, if you forgot, immediately derive. By any integer would be what form? Either it will be 4n form, or it will be 4n plus 1 form, or it will be 4n plus 2 form, or it will be 4n plus 3. Plus 3 also you can write minus 1. Yes or no? Plus 3 we can write minus 1, because plus 3 means plus 3 plus 4 minus 1, 4. So it will come 3. If you square, the here remainder will be what? 0. If you square, here remainder will be 1. Here remainder will be 0, because 2 can be common and square it, so 4 will be there in multiple, and here remainder will be 1. Means if you divide any perfect square integer by the 4, remainder will be either 0 or 1. Are you agree with me or not? Yes or no? If you divide any integer square by 4, remainder will be 0 and 1. Somebody can think, sir, why you are thinking, why you are, how you are getting this idea? By looking this, I got this idea. 16. Oh, this is divisible by 4. What I will do? I will divide both sides by 4. A square plus 16b equal to 5. I am dividing by 4. Divide by 4. By 4 both sides. So, bhai, right side, hello, right side remainder will be what? Right side remainder will be what? 1. If you divide 5 by 4, what is the remainder? 1. Did you understand? Is it clear? Now next. If you divide this side by 4, so what the remainder here? 0. And what is the remainder here? Either 0 or 1. If it's coming 0, it's okay. Then they cannot be equal. Right? 0, left side remainder will be what? Think carefully. A square, if you divide, remainder will be either 0 or 1. 0 or 1. 0 or 1. 0 or 1. Listen me carefully. 0 or 1. Plus, this is 0. Means left side, either remainder will be 0 or 1. Oh, then it can be equal. There is a chance. There is a chance. All of you able to understand? There is a chance is happening. So what should we do? I am also trying simply. I am not doing the things careless all. But now left side and right side can be equal or not. If this 0, they will not be equal. But there is a chance that this left side also 1 and right side also 1. So we'll say that remainder are equal. So maybe they will be equal. Maybe root solution will be there. Okay. Let's change our strategy. I will divide by 8. I will divide by 8 both sides. First thing is that 8 if is there. So what is the possibility? 8n plus 1, 8n plus 2, 8n plus 3, 8n. I know I am doing very lengthy method, very lengthy, but believe me, It's worth it. I'm doing for particular purpose. 8n plus 5. 8n plus 5, what I can write? 8n minus 3. 8n plus 6, I can write 8n minus 2. 8n plus 7, I can write 8n minus 1. If is square, this is remainder 0, here is square, remainder 1, here is square, remainder will be 4, here is square, remainder will be 1. Did you understand why? Because 3 is square, remainder only, we have to check. Here remainder will be 0. Yes or no? Here remainder will be 1. Here remainder will be, how much will come? 4. And here remainder will be 1. Means, if I will integer is square, I will divide by 8. Remainder will be either 0 or 1 or 4. Now, same question, I am going to divide by 8. This 8. I know that if I will square, any integer is square, I will divide by 8. Remainder will be either 0 or 1 or 4. So, if you divide by 8, this right side, what is the remainder? Speak out. Right side remainder will be 5. Right side remainder will be 5. Remainder will be 5. Left side, think. Left side, whatever remainder from here plus whatever remainder from here. A square will give you remainder what? Either 0 or 1 or 4. Speak out. Anyone. Not all three. Anyone. And this will give you remainder what? 0 only. So left side remainder will be either 0 plus 0 means 0, or 1 plus 0 means 1, or 4 plus 0 means 4. But right side remainder is what? 5. Means it's impossible that these two can be equal. Did you understand? I'm just giving you one possibility of solving the question. When I divided by 4, I found that there is a chance. Then immediately I got the idea, if there is a chance to solving this question, it's really difficult. Correct? So I did by this method. I divided by 8 and verify. Didn't understand. Hello? Should I tell you some other way? Simple way. Let me explain some other way. By this way only we learn mathematics. 16b equal to 5. Now I am going to make the cases. First case. Let's say A is even. A is even. If A is even, A square will be also even. And 16b already even. Even plus even, it will be even. Hello. And this is the odd. Even cannot be equal to odd, no solution. Means one thing is very sure, this equation does not have solution for even value of A. Second possibility, A is odd. A is odd. If A is odd, immediately your idea should come. A square I can write 8m plus 1 plus 16b is equal to 5. Or you can say 8m plus 16b is equal to 4. Or you can say 8 common here, m plus 2b is equal to 4. 4 bye bye. 2 into m plus 2b is equal to 1. Yes or no? 2 into something integer, that is the even, and this is always odd. Even equal to odd. Array, impossible. Means no solution here also. Means this equation does not have solution for a even value of A as well as odd value of A. Means this equation does not have the solution. I am sure ki able to understand everybody. Is this clear? And let's do the last question and finish it off. Every question, any questions, if you have doubt, you can put up to me. I will surely help you out. Right? And go through every question once again. What point you learn from that? What you have to keep in. Actually, in this lecture, I am trying to teach you only that the odd square will be in the form of 8m plus 1. Any number, any integer is square, if you divide by something, what will be remainder? These are the things I am trying to tell you, nothing else. And now, a beautiful question, which was asked in sometimes in some examination, I don't know which examination. Write down. Find number of integer A. Find number of integer A so that A plus 2, a plus 4, all are in prime. All are prime. Beautiful question. And beautiful solution. Simple, straightforward. First thing, read question carefully. Don't go by hit and trial method. Of course, this question can be solved by hit and trial method also. As I told you, shortcut at the end. When you finish whole syllabus, you are ready for writing examination, then some kind of shortcut, this way, that way also you can get the answer, but not initially, otherwise whole maths will get spoiled. Find number of integral value of a so that a and a plus 2, a plus 4, all three should be prime number. Yes or no? Okay. First thing, what is the prime? Prime number, any number which is having only two factor. Any number, any integer which is having two factors. What is that two factor? 1 and number itself. And number itself. Any integer, if it's having more than two factor or less than two factor, will not be prime. Exactly two factors. And there is the only one even prime is there. Even prime, only one, that is 2. All other prime numbers are the odd prime numbers, odd integers. Only even is, this is the 2 is only, so what is the prime? 1 is prime? No, because 1 having only one factor, 1 itself. 1 having only one factor, 1 itself. And what is the prime definition? 1 and some other, that number, that integer. So 1 is not a prime, 2 is a prime, 3 is a prime, 5 is a prime, 7 is a prime, 11 is a prime. Yes or no? And so on. Correct? On the prime we'll discuss much more later stage, because prime is the beautiful things. Still people do research on it. Okay? So let us say, right now I just basic idea I given you. Right? And another is the composite number. Composite number. What is the composite? Any integer which is having 3 or more than 3 factors. Any integer which is having 3 or more than 3 factors will be called as the composite. Any integer which is having 3 or more than 3 factors will have the called as the composite. Like 2. 2 is having only 2 factor, 1 and 2. 3 only 2 factor, 1 and 3. 5 only 2 factor, 1 and 5. That's why these are called as the prime number. You know, people say prime locality, prime location. So this is the having some weightage. Composite. If I say 4 having the factors, what factor? 1, 2 and 4. 3. So it's a composite. 1 is what? It's not composite because it's having only one factor. So 1 is neither prime nor composite. 1 is neither prime nor composite. Perfect. Let's go ahead. I hope all of you understood the idea. Is it clear? Prime having so many other properties which we'll discuss later. Okay, beautiful properties are there for the prime numbers. Okay, I have to check it. So now I will take A can be any integer. So I will take 3 cases. First case, A can be 3m. A can be 3m. If A 3m, this will be, what will be written? 3m. 3m plus 2. 3m plus 4. Correct? I will come back to this. Don't worry. Second case, A may be 3m plus 1. If A is 3m plus 1, so how this number will be written? 3m plus 1. 3m plus 3. Why 3m plus 3, sir? Because A plus 2 means 3m plus 1 plus 2. And 3m plus 4. 3m plus 5, sorry. Carefully watch. Okay. We'll come back. Third case, what is the possibility? A equal to 3m plus 2. A equal to 3m plus 2. Put it here. 3m plus 2. 3m plus 4. And 3m plus 6. Let's start. In this 3 number, carefully watch. M whatever. But this is prime always. Composite. hello, m whatever, this will be always composite. Why composite? Are 3 you can take common. 3 into m plus 2 will come. 3 into m plus 2 will come. Somebody can say, sir, 3 into m plus 2 will come. So how can you say it's a prime? Composite, because this is having 2 factor already, and 1 of course is there. So 3 factors will be there minimum. M, maybe some of you can think, sir, m equal to 0. M equal to 0, then 100% is a composite. M equal to, sir, minus 1. M equal to minus 1, it will become prime. But if m equal to minus 1, this become prime, this become non-prime. M equal to minus 1, put it here. Minus 3 plus 2. Here. M equal to minus 1, here put it. Minus 3 plus 4, 1. And 1 is not a prime. This will become prime. But this will become non-prime. And for any other value of m except minus 1, this will be not prime. So, all 3 cannot be prime together. So, this case, impossible. Yes or no? Means this will, no value of m is there for which this kind of integer can be, all 3 can be prime. Come here. Concentrate. This is not a prime. This is a composite. Why composite, sir? 3 I can take common. I will get m plus 1. So 3 into something. They will say, sir, m equal to 0 I will put. M equal to 0 you will put. So this will become prime, but at the same time this will become non-prime. All 3 should be prime, na? M equal to 0, this is always composite except one case. Which case? M equal to 0. M equal to 0, if you put, this will become prime. But if m equal to 0, you will put here, it's prime, but this will become non-prime. And if m is not 0, this will be always composite. This will be always composite. M equal to not 0, 1 or 2 or 3, this will be always composite. So all 3 cannot become prime. Impossible. Now coming to this. Here, I cannot comment on these 2, but I can comment very much on this. This is composite except 1. What is that? Hello? Except one value of m, it's a composite. What is that? M equal to 1. If m equal to 1, this will be prime. M equal to 1, this will be also prime. M equal to 1, this will be also prime. Perfect. Only one value of a is there when m equal to 1. When m equal to 1, all 3 will become prime. If m is not 1, this will be always composite. So all 3 cannot be prime. So only one value of a is there. A equal to, don't say a equal to 1, m equal to 1. M equal to 1 is a equal to 3. A equal to 3 is the only solution of this question. Beautiful question. Logical question. I am not talking about that, how fast we can solve it. I am trying to teach you that something by which you can utilize Euclid Division Lemma. I hope all of you understood. One of the beautiful things. So this is the Euclid Division Lemma. You need to do the question practice. Be clear right now, if you do question practice from different book, of course you will face little bit difficult, not little bit, very much difficulty if you never learn number theory. Because this is a very small portion of the number theory. Now, the next segment which we are going to learn, that is the GCD, greatest common divisor, or you can call it as HCF. Highest common factor. Generally, this is the more popular name in the 9th and 10th class students. Same thing, this is the GCD is the heart. See, 3 things is there in the whole number theory. If anybody confident about these 3 things, it's done. 1, Euclid Division Lemma. Second, GCD. GCD contains so many Bijou equations and all so many things is there. And third, congruency. These 3 things, anybody knowing, they can solve number theory question up to RMO. INMO, I cannot give any guarantee. That depends on the child ability. But till RMO, you will never face problem in the number theory. Right? So for today, this much only. Please revise all these things. In case of anything is confusion or any point, please give the comment and you can send to me. Well, surely I will look into this. Thank you very much and see you in the next class of the GCD.